Yes, hi class. Hi, good evening all. How are you all? Very good evening to the fresh session in the Target Gate 21 batch. Control systems is the subject we are starting, and the very important and the interesting subject of Nyquist plot is we are going through, right? Good evening, good evening, good evening all. Yes, control system, and we are on to one of the very interesting topics of the Nyquist plots. Yes, I'm fine. I'm all fine, my dear students. Hope you are all fine at home, safe at home, enjoying your studies, enjoying the lockdown studies. Must be a good time that you're able to get enough time for preparation right now. Okay, so did you all complete the homework? What was the homework? I'm not talking about the question homework, but one very important homework I have given you yesterday. And that is because yesterday we learned about the very important development of the Nyquist stability criteria that is given by n is equal to p plus minus z plus, how it comes up, why we talk about the encirclement minus 1 comma 0, how we talk about the closing from minus j0 to plus j0. All these steps were done yesterday, and we also started with basic questions of some Nyquist or polar plots. Okay, and today is the continuation of the class. Today is the continuation of the class. So we'll be solving more variety of cases today in this class, and I'll introduce step by step. Let me solve in the classical method, and then so that concept once it goes into the head, then it will be easy to understand the tricks and relate. So slowly we'll come to the tricks as well, how to solve the problems quickly if it is a MCQ question, because sometimes MCQ questions can only be solved by matching the options by the shape, by getting the shape of the polar plot. To how to get to the shape and all that we'll all see, right? Sorry. So let me just quickly go through of the yesterday's class. Yesterday we had lots of discussion. I'm not talking about the derivation. So quickly after discussing the derivation n equal to p plus minus z plus, I came to the procedure for sketching the Nyquist plot, wherein we were focusing the polar plot first. Okay, so I had given you the steps to sketch the polar plot, Cartesian form, Euler form, 0 plus, infinity plus, critical frequency अभी तक नहीं देखा है हमने, but we'll also see critical frequency today coming up. Okay, and then after completing till now we were focusing only on the polar. Okay, but after taking few more examples of polar, I will go to the complete Nyquist sketching. Or to complete the Nyquist plot, I will have to plot for negative frequency. That is done by taking the mirror image, and then I will close the point from minus 0 to plus 0. Close the point from minus 0 to plus 0, and that is obtained by rotating through an angle of n pi. That is obtained by rotating through an angle of n pi, where n is the number of poles of GSHS at origin. All right. So I gave you some basic complex number. I'm repeating whatever we did from the procedure. Yeah, these were some basic. I gave you one question and I was observing not everyone giving the correct answer. That is why I went on and revised some basic complex number analysis for you. These are the important formulas that you must necessarily remember while solving a Nyquist or polar plot example. Okay, so first quadrant, whether it is first quadrant angle, second quadrant angle, I've given you all answers. Tan inverse y by minus x is 180 minus tan inverse y by x. Third quadrant, fourth quadrant, and apart from that, very important, what is the angle on any coordinate axis, that must be known. This is very helpful in solving the questions. Angle at all the coordinate axes, we had seen this one, and then we started with some examples, like we started with 1 by s. Okay, the simple polar plot, we took 1 by s square. Now the polar plot lying on the negative real axis, and then we took 1 upon 1 plus xt, 1 upon 1 plus st, the polar plot lying in the fourth quadrant. How do we decide the quadrant? ये भी हमने कल discuss किया था. How do we decide the quadrant of the polar plot? This was the final polar plot for 1 upon 1 plus st. This is also solved yesterday. And then we took the last case yesterday, that is 1 by s 1 plus st. That was our last case, and now we'll continue after this case. We had completed the Nyquist polar plot of this as well. 1 upon s 1 plus st. It is in the third quadrant, again by the knowledge of x and y. The Cartesian form I commented, the third quadrant. Okay, and omega equal to 0 plus infinity plus, we came to this plot. This plot which also has an asymptote at omega equal to 0 plus, and what is that asymptote? It is parallel to the y-axis. If you want to give the name to this asymptote, this asymptote will be represented by, I will write it here, this asymptote is represented by the equation that is line parallel to x-axis. It is a line parallel to y-axis, sorry. It is a line parallel to y-axis. So line parallel to y-axis has the equation x equal to constant, and the value of that constant is minus t. The value of that constant is minus t, x equal to minus t. Okay. So this can be the name to this asymptote that can be written. Okay. And then thereafter, yeah, there is also in some books I told, in the before question at 0 plus parallel to the x-axis. No, it was lying on the x-axis. It was not parallel to the x-axis. It was just lying on the x-axis actually, Nikhil. Yeah, there is also the wrong method of sketching, although it does not affect the stability analysis. But yeah, these are the wrong plots. Why it is wrong, I told you yesterday. And now this is what is the homework that was given by me. First one is the revision of the whole lecture, the yesterday's whole lecture. That was to be done till 4 p.m. today. I hope you have followed that. And then I gave you two questions. I believe you must have a little bit tried on these questions as well. 1 upon s square into 1 plus st. Now guys, I will start the questions, and step by step as the time demands, I will give you some shortcuts. Okay, as the time demands. Okay, but unless and until okay, that was the first homework question. 1 upon s square 1 plus st. 1 upon s square 1 plus st. Now follow with me. If you have tried it, just match the final results. Let us do it some more calculations so that I am able to explain you critical frequency. जब तक critical frequency explain नहीं करता तब तक मैं shortcuts नहीं बोलूंगा. And then gradually I will tell you few shortcuts. Sketch the polar plot for GSHS equal to 1 by s square 1 plus st. So first of all, converting. Guys, if you have solved this, obviously in the comment box you can't say the diagram in the comment box, but at least can you say the quadrant if you have solved this, in which quadrant this plot is lying? Yeah, hi, good evening. In which quadrant is it lying? 1 by s square, that is j omega square 1 plus j omega t. Yeah, at least if you will tell me the complete quadrant, it will be clear that yes, you have tried. Yes guys, come on. Right, so many are telling second quadrant. That is correct. That is correct. No, Sarthak, it's not in second and third. It's only going to be in the second quadrant. It's only going to be in second quadrant, not in the third. No portion of it will go to the third one. Okay. Chaliye, so how it is so? Let us see that. This is equal to, now first of all, denominator x plus jy, so I will rationalize it by 1 minus j omega t. Now denominator j omega whole square, so j square is minus 1 anyways, into 1 minus j omega t, niche bhi multiply kiya, so it is directly 1 plus omega square t square, like yesterday. Whatever calculations can be continued from yesterday, I will continue that. Okay. Yes guys, come on, very good, that is correct, second quadrant mein hoga. Now breaking into real and imaginary part, it is minus 1 by omega square 1 plus omega square t square minus, now you see minus minus is actually getting cancelled, so it is plus j omega and omega, one of the omega will be cancelled, so j t upon omega 1 plus omega square t square. Okay. Alright, so what is x and y? If I write this separately, x is minus 1 by omega square 1 plus omega square t square, which is negative, and y has turned out to be positive. Okay, minus minus cancelled, so y is equal to t is divided by omega 1 plus omega square t square, which is positive. X negative, y positive gives the second quadrant plot. It is lying in the second quadrant. It is lying in the second quadrant. Okay. Now, apart from that, let me calculate the Euler form. And for Euler form, I need the magnitude and phase. What is the magnitude of this complex number? 1 upon omega square, and magnitude of 1 plus j omega t is written as under root of 1 plus omega square t square. That is the magnitude form. And what is the phase form? Phase form, see, like yesterday, numerator is positive real number, so phase kitna likhenge? 0. Denominator is j omega. Now j omega pure imaginary number, what is the phase? 90 degree. But it is j omega square, so j omega into j omega, and when two numbers are multiplied, the angles are added. So 90 degree will occur twice. 90 degree will occur twice, and then the phase of 1 plus j omega t, that is tan inverse y by x. Okay, so finally, just a second, what is coming here? Just a second, guys. Not got enough space here. Okay, so finally, what I am getting the phase as minus 180 degree plus tan inverse omega t. Okay, minus 180 plus tan inverse omega t. Now, I want to see the results at omega equal to 0 plus and infinity plus. Omega equal to 0 plus. See the value of x. Omega, x and y both denominator में omega है, तो omega 0 रखते हैं infinity. X is minus infinity, y is plus infinity. Okay, magnitude is also 1 upon 0. See, magnitude also has omega in the denominator. 1 upon 0 infinity. Phase is equal to, yeah, that is minus, correct. That is minus. Okay, yeah, I've made that minus. Denominator term है, minus में ही रहेगा. Okay, and phase is equal to minus 180 degree minus tan inverse 0. Tan inverse 0 is just 0. Okay, at omega equal to infinity plus x is equal to, omega is only in the denominator, so minus 1 by infinity is 0. In y also omega is in denominator, 1 by infinity 0, and x equal to 0, y equal to 0. Again say that the Nyquist plot will be going towards origin, diving towards origin. Magnitude 1 upon infinity, that is 0. That also means origin. And phase is equal to what? Phase is equal to minus 180 degree minus tan inverse omega t, omega infinity. Tan inverse infinity is 90. So 180 and 90 minus 270 is the phase. Okay, I hope you have the same calculations. Minus 270. Okay, I hope you have the same calculations. Now, with these calculations coming into picture, let me complete my Nyquist, polar plot right now. Yes, 190 or minus 270, both are equal angles only. The real axis, this is the imaginary axis. Now look at my coordinates. At omega equal to infinity plus की बात करते हैं पहले. At infinity plus, I have to be at origin. Okay, I have to be at origin such that the angle is minus 270. Minus 270 is which axis? Minus means clockwise. Clockwise 270, matlab positive y-axis actually. Positive y-axis. So you have to come and dive into the origin. You have to come and touch the origin such that, what I have explained you yesterday, how will you approach origin? Such that the polar plot, okay, polar plot is tangential to the minus 270 degree line, and minus 270 degree matlab positive y-axis. So something like this. It is in the second quadrant, that I have made it clear in the beginning. That is why I am going for the second quadrant only, making the plot towards second quadrant, but it has to be tangential to the positive y-axis. This is minus 270 degree line. This is infinity plus. And then at omega equal to 0 plus, okay, omega equal to 0 plus, magnitude infinity, phase minus 180. Phase minus 180 means along the negative x-axis, either negative x-axis or parallel to it. Phase is minus 180, matlab along the negative x-axis. Direction pata hoga. Maybe negative x-axis or parallel to negative x-axis. And to give you the correct shape, that is why I have done the x and y analysis. X is minus infinity, y is plus infinity. X is minus infinity, y is plus infinity. Matlab it is just going to go and travel. Once again, why I'm telling you this, because I'll tell you again, in some of the Indian author textbooks, the graphs are given to be like this. This is the wrong graph for 1 upon s square 1 plus st. This is not correct. Why it is not correct? Like I've explained you yesterday, you can look into the denominator. Omega is in denominator. Okay, omega is in denominator directly. Numerator is constant, and you are decreasing omega from infinity to 0. I am going towards 0 plus. In decreasing the omega should increase the values of x and y. X is negative, matlab going towards negative side, but the magnitude of x and y should increase. So x going left, y going up. X going left, y going up. Jabki this graph represents what? कि the y increases and then y decreases, but that is not possible as per our complete pure mathematical analysis. Okay, so I'll just remove this. This is the incorrect graph, and now whatever I have sketched, that is the correct graph for this one. That is the correct graph for this one, and this represents 0 plus. Arrows are taken from 0 to infinity in the increasing value of omega, obviously. This is the polar plot. Understood, guys? This is the polar plot. This is the polar plot. Okay, polar plot for 1 by s square 1 plus st. Okay. All right. Yeah, how it is equal to pi or minus pi, whatever, because it is along parallel to the negative real axis. And what is the angle? Two parallel lines, matlab I am talking about same direction, same phase. What is the angle of negative x-axis? It is pi or minus pi. And this polar plot is going to be just parallel to the negative y-axis towards infinity. Okay. Okay, Yashwant? Now guys, listen, see the yesterday's plot. See the yesterday plot. I will sketch it again. No problem. I'll just sketch it again. Yesterday, the last question that we did was 1 upon s 1 plus st. 1 upon s 1 plus st. And the question that I have done right now is 1 upon s square 1 plus st. Now guys, please observe here. What is the difference in the two function? What is the difference in the two function? That I have added one open loop pole. Why open loop pole? Because we are talking about GSHS function at origin. Add one open loop pole at origin, and what is the effect on the polar plot? What is the effect on the polar plot? You add a open loop 0 at origin. What is the effect on the polar plot? Observation of effect boliye. What is the observation effect? Yes. Quadrant shifting in what direction? Quadrant shifting matlab shifting the polar plot by 90 degree. Yes, angle is shifted. See why the angle is shifted? The simple reason is here the phase is minus 90 minus tan inverse omega t. But for this case it is minus 180 minus tan inverse omega t. Yes, Mihira, X was bounded, but I'm talking in the sense of direction right now. So when you add an open loop pole at origin, the total phase of every point is actually shifted by minus 90. It was minus 90 and now it is minus 90 two times. Okay, so because of this minus 90, the polar plot is shifted by 90 degree, and because of minus, it is shifted by clockwise. It is just equivalent to shifting the plot third quadrant into second quadrant. Okay, third quadrant into second quadrant. Shubham, nothing about stability here. This is open loop transfer function. Stability will be taught about when I take the closed loop transfer function, and for the closed loop transfer function, I will take the Nyquist plot. I will take the formula that I have discussed yesterday, n equal to p plus minus z plus. Okay. So this is the first point. Others I will also come to. Just note this first point. General effect of addition of open loop pole at s equal to 0. Okay. Omega equal to 0 plus and omega equal to infinity plus. Both the points are shifted by 90 degree in the clockwise sense. 90 degree in the clockwise sense. That is what we have seen now. 0 plus, it was along the negative y axis. Now ye move hoke chala gaya negative x axis ke along. This is the movement in which direction that it is pointing. 0 plus किस direction में point कर रहा है? It was towards negative y axis. Now it is pointing towards negative x axis. Negative y to negative x. Matlab the direction has changed by 90 degree clockwise. Similarly, infinity plus point, it was pointing about negative x-axis. See, this is the negative x-axis and now it is tangential to positive y-axis. Negative x-axis to positive y-axis, this is also 90 degree clockwise. This is also 90 degree clockwise. Okay, actually पूरा plot ही change हुआ, but I am giving you the shortcut in the form of 0 plus and infinity plus. Okay, both the 0 plus and infinity plus point will be shifted by 90 degree in the clockwise sense. Okay, rest I will talk about this one. Wait about this. Second homework question जो था वो इस पे depend करेगा. First, just understand the point number 1. Clear? And if this is clear, guys, let us do one activity. Addition of open loop pole at origin. This is the effect of addition of open loop pole at s equal to 0. Please say, is it clear or not? Everyone, guys, be interactive because there's an important discussion going on. I want your comments. I want your replies so that we do one small activity by the knowledge of this fact. Come on, guys, quickly. Okay, guys, come and observe. 1 upon s into 1 plus st is what we started with yesterday. This was the plot. This is 0 plus. Make it go towards infinity plus. Okay. Then the next plot that we have just solved right now. This is for 1 upon s square 1 plus st. 1 upon s square 1 plus st. Okay. Next one. Yes, Nitesh, please refresh. If I introduce one more open loop pole, what will happen? If I introduce one more open loop pole, that is 1 by s cube 1 plus st. 1 by s cube 1 plus st, what will happen? It will again be shifted by, so this was infinity plus along positive y-axis, make it to 90 degree clockwise, the positive x-axis, and it will go like this. It will go like this. Yes, Verma, it's going to be in the first quadrant. This will represent 0 plus actually. Okay. And the last one, what will happen? Okay, the last one more open loop pole at origin. So this will be shifted. The infinity plus point will be along negative y-axis. It will go like this. This will be 0 plus again. This is common. This is infinity plus point. But the way it is touching the origin is not same. Sometimes it is touching along x-axis, sometimes along y-axis. Okay. And let me write down the function also. This one represents 1 upon s raised to the power 4, 1 plus s. I have told you for all the 4 cases. You can remember it like that. How can you remember it? Does this shape resemble anything? Only thing you have to remember, okay, you have to remember, yeah, slight change of shape, but yeah, it will again go back towards the first one. You have to remember that this is 1 upon s 1 plus st, and then if you keep on adding the poles at origin, it will get shifted 90 degree clockwise. It's like, you can say it like blade of a, yes, swastik also you can say the blade of a table fan, something like that. Exactly, Verma, that's what I'm telling, table fan. Is it like MI logo? I'm not really aware about that. I don't remember the MI logo. Is it like MI logo? I'm not really aware about that. If it is so, then that's good. Yes, windmill. Okay, blades of a fan, basically blades of a fan. All right, चलिए, तो let's move forward. Let's move forward. Okay, चलिए, let's move forward then towards the next homework discussion. This was the next homework yesterday that I gave you. 1 upon S, 1 plus ST1, 1 plus ST2. Okay. No, Saurabh, 1 upon 1 plus ST is different because that will have a finite value. That will have a, because that is type 0. That is type 0. At omega equal to 0, there is no 1 upon 0 term. So it is lying on the positive x-axis at a finite point. It is not going towards infinity. That is why I am not bringing that in the picture. Okay. Yeah, if you have solved this, you can tell me the quadrant. Shape you can't comment, but at least you can comment the quadrant. At least you can comment the quadrant. Gj omega Hj omega is equal to 1 by j omega 1 by j omega 1 plus j omega t1 1 plus j omega t2. Yes, guys, this is not going to be in one single quadrant. It is going to be in the combination of two quadrants. Yes, that is second and third. Correct. It's not in one quadrant. It's going to be in two. Now, what will you do? You will rationalize the terms 1 minus j omega t1, 1 minus j omega t2 divide by j omega. The first one will become 1 plus omega square t1 square. Second is 1 plus omega square t2 square. Okay. Now, simplifying the numerator, what you shall get, I will just write it here, 1 minus j omega t1 plus t2 minus minus plus j square omega square. J square is again minus 1. So, minus omega square t1 t2 divided by j omega 1 plus omega square t1 square 1 plus omega square t2 square. Okay. Now divide by j omega. This j omega and this j omega will cancel. And if I split the term, that means this part will become real. So I have gj omega, hj omega as minus of t1 plus t2 divided by 1 plus omega square t1 square 1 plus omega square t2 square after cancelling this one, j omega, j omega. Okay, then the other one, 1 and minus omega square t1 t2, uske saath divide by j omega and 1 by j is minus j. 1 by j is minus j. 1 minus omega square t1 t2 divided by, there is a omega, and into 1 plus omega square t1 square into 1 plus omega square t2 square. Correct? Now, this is of the form x plus jy. X plus jy. Okay, which quadrant? This is of the form x plus jy. So, it is in which quadrant? And that is x equal to minus of t1 plus t2 divided by 1 plus omega square t1 square 1 plus omega square t2 square, and that is coming with a minus sign, so obviously x is negative, but y is equal to minus of 1 minus omega square t1 t2 divided by omega 1 plus omega square t1 square 1 plus omega square t2 square. Now whether this is negative or positive, no, we can't say it is third quadrant. Y is not always negative because the numerator is of the form 1 minus omega square t1 square t2 square. That means if 1 minus omega square t1 t2 is positive, so minus of positive, that means y will be negative. Okay, and if 1 minus omega square t1 t2 is negative, the negative of negative will produce y as positive. Okay, and if y is negative, guys, x is anyways negative, x and y both negative, so that is third quadrant. Okay, and x negative, y positive will represent second quadrant. Okay, so it may be in the third quadrant or it may be in the second quadrant based on 1 minus omega square t1 t2. That means That means now this frequency has a little bit important. This frequency has a little bit of importance. That is why I am solving in detail. Many of the concepts will be opened by this question. 1 minus omega square T1 T2, if it is positive, that means omega is less than 1 upon root T1 T2. Omega is less than root 1 upon T1 T2. Okay. And when 1 minus omega square T1 T2 is positive, Y is negative, and that is the case of third quadrant. Third quadrant. Then next what I have shown you, 1 minus omega squared T1 T2, if it is negative, so Y becomes positive and the graph goes to second quadrant. When does the graph enters the second quadrant? When omega is greater than 1 by root T1 T2. So guys, what happens exactly at omega equal to 1 by root T1 T2? What happens exactly at omega equal to 1 by root T1 T2? Okay, the Nyquist plot will be changing from third to the second quadrant. Okay, will be changing from third to the second quadrant. The plot will be moving from third to second quadrant. And when you go from third quadrant to second quadrant, what is the axis that you cut? What is the axis that you cut? Okay. What is the axis that you cut? Y becomes 0 and you cut the x-axis. Which x-axis? Third to second, matlab negative x-axis. Okay, so this is the point of intersection. This is the point of intersection with negative x-axis. This is the point of intersection with the negative x-axis. Point of intersection with the negative x-axis, negative real axis. Okay. Now, this is altogether related with so much of important concept, that is stability. I am going to call it as a phase crossover point. Okay, मैंने बोला ना stability को हम link करेंगे. अभी right now my intention is to show you the variety of graphs. Okay, and that is why I told before giving you the tricks, I am talking about the details of every problem. So I have got a point when the Nyquist plot cuts the negative x-axis. First of all, I define a point known as critical frequency here. A point known as critical frequency here. That is not the phase crossover frequency. Phase crossover frequency I will define once we start stability. Once we start the gain margin, phase margin concept also. But critical frequency with respect to yesterday, step number 6 of polar plot. मैंने बोला था let the critical frequency be blank, be suspense. What it is, I am going to explain you with some question. So what is critical frequency? Critical frequency in a polar plot, it is a frequency at which the polar plot intersects what? Intersects any coordinate axis, not only x-axis. The polar plot intersects any coordinate axis. I will call that frequency as the critical frequency. And what is the critical frequency here in this question? Here in this question, the critical frequency is 1 upon under root of T1 T2. Okay, now this critical frequency has to be solved quickly by the Euler's method. This is the Cartesian analysis. Yes, here 1 upon root T1 T2, it is the Euler method. It is the critical frequency. Now going for the Euler form. How to find the critical frequency by the Euler form? That I have told you, but did not explain yesterday. Now I'm going to explain it. So what is first of all Gj omega Hj omega? Let us rewrite, and that is equal to, guys, 1 upon j omega 1 plus j omega T1 1 plus j omega T2. So what is the magnitude function? Is 1 upon omega root over 1 plus omega square T1 square root over 1 plus omega square T2 square. And what is the phase? Equal to numerator 0, denominator के लिए directly write minus of सबसे पहले 90 because pure imaginary term, minus tan inverse omega T1 minus tan inverse omega T2. Minus 90 minus tan inverse omega T1 minus tan inverse omega T2 is the phase. Okay. Now, let us first complete the 0 plus and infinity plus calculation as we always do. Omega equal to 0 plus and infinity plus. Omega equal to 0 plus and infinity plus. What is the x and y first of all? So let us go to the x. X is equal to, okay, write it here. X is equal to omega को 0 place किया तो denominator is just 1. X is equal to minus of t1 plus t2 and y is equal to, see, in the y it is minus 1 by 0. Omega is in denominator. Minus 1 by 0 means minus infinity. Okay. What about the magnitude? What about the magnitude? See, magnitude is again 1 by 0, that is infinity. And what about the phase? Phase is minus 90 minus tan inverse 0. Tan inverse 0 is just 0. The phase is minus 90, and then I will complete the calculations at omega equal to infinity plus, and that is x equal to, let us see x and y. Omega is in denominator. Okay, so 1 upon infinity 0. Here omega is in numerator also, but degree of denominator is more. I told degree of denominator more, so answer 0 ही रहेगा. So x is minus 1 by 0, minus 1 by infinity, so that is 0. Y is also of the form minus 1 by infinity, that is 0. So clearly again we get a point, that is origin. How to identify origin? By magnitude. So magnitude is also 1 upon infinity case, that is 0. It also means origin. Phase is equal to minus 90 tan inverse infinity minus 90 that is minus 270 degree. That is minus 270 degree. Correct? That is minus 270 degree. All right. So now how to proceed? How to complete the plot? How to complete the plot? Okay. So I will now show you the calculation of the critical frequency using Euler method, because in every question now we will not apply the Cartesian steps. Cartesian steps every time, rationalizing, simplifying, observing the quadrant not required. Just calculate the omega c using Euler. Okay. That too, it will be required in those cases where you are going to plot the complete plot for stability. If only shape is required, to match the option A, B, C, D, for that I will give you a more better shortcut. Okay, but if stability analysis to be done, so omega c is very important. Without this calculation, we can't comment on the stability analysis. So how to calculate the omega c using Euler method? If you remember the step number 6, I'll take you towards the beginning. For a moment. Polar plot. Yesterday I've given you some steps for the polar plot, and there I mentioned the critical frequency word. Right. Obtain the simplified formula of phase in terms of tan inverse, and then equate the numerator and denominator which are inside the tan inverse to 0. That is what I have told you yesterday, and that's what I am going to do here now. So what is my phase, guys? It is minus 90 minus tan inverse omega t1, and let me take this minus outside, so it becomes plus tan inverse omega t2. Tan inverse A plus tan inverse B is how much? Tan inverse A plus tan inverse B is how much? It is given by the identity tan inverse of A plus B divided by 1 minus AB. 1 minus AB. Okay. And then this is the simplified expression. Okay. There were two tan inverse terms. I have simplified tan inverse A plus tan inverse B is tan inverse A plus B upon 1 minus AB. And then what I told, equate the numerator to 0. And guys, if you equate the numerator to 0, the only frequency that you get is 0. Okay, the only frequency that you get is 0. And what are the results of 0 that already considered? That is already considered. So don't consider the 0 in the critical frequency. So now take the denominator. Denominator equal to 0. So equating the denominator to 0, you get omega c as 1 upon root t1 t2. Same value I am getting now that I have explained you in the Cartesian step. But suppose the Cartesian steps are not done, only I am solving the problem by Euler. But I am getting the same answer, 1 upon under root t1 t2. 1 upon under root t1 t2. Okay. So this is the critical frequency. But how did I define the critical frequency? It is a frequency at which you can intersect any coordinate axis. Any coordinate axis. So which coordinate axis you are intersecting actually? Which coordinate axis you are intersecting actually? So that also can be obtained by Euler one only. Omega c equal to 1 upon root t1 t2. What is the phase? Phase is minus 90 minus tan inverse of, just follow with me, tan inverse of some numerator divided by 0. Denominator को 0 करके तो ये equation आया है. तो some numerator divided by, there is some numerator which is positive divided by denominator is 0. That is how you got the critical frequency. So it is tan inverse infinity again inside. 1 upon 0 is infinity and that is 90. So minus 90 is minus 180. So phase is minus 180. It signifies the phase obtained is minus 180. It signifies it is negative real axis. So at what axis you cut? It is negative real axis. At negative real axis. Okay. Negative real axis. Negative x axis pe cutting hoga. That is what was obtained by the Cartesian analysis. Okay, you are going from the third quadrant to the second quadrant. But now imagine that my Cartesian analysis is not done. I am only doing the Euler analysis. So how to get which axis from the Euler analysis? I check the phase. Okay, I have told you phase of all the 4 lines, positive x, positive y, negative y. So you can identify which axis it is. It is negative x axis, negative real axis. Okay, and what is the magnitude at this point? At omega c equal to 1 upon under root t1 t2, magnitude will be equal to c. Magnitude will be equal to, yahan pe I will put omega equal to omega c here. After putting omega equal to omega c, what is the result that you will get? I am giving you directly. T1 T2 is divided by T1 plus T2 after solving this, after putting omega equal to 1 upon root T1 T2 here. Okay. You can try this. It's a very simple exercise, just one line exercise. I have given you the direct answer. T1 T2 divided by T1 plus T2. Okay. Now, I will sketch my plot. And guys, just follow the plot with me. There is one more reason I have completed the Cartesian analysis to give you the exact shape of the Nyquist plot, because once again in the Indian author, some books, you will get the shape as like that. But this is not the case. What is the correct shape that I am going to tell you? By the 0 plus and infinity plus point first of all. 0 plus p. Okay, 0 plus p. Yeah, let us see infinity plus p. First infinity plus p, the magnitude is 0, matlab origin point. But with phase minus 270. Phase minus 270. Okay. Touching the positive y-axis. Minus 270 means positive y-axis, right? Then going to omega equal to 0 plus x is negative, y is minus infinity. X and y both negative, matlab third quadrant. That is why because you are going towards negative y-axis, that is why the phase is minus 90 degree. Matlab, if this is infinity plus point, where should be 0 plus point? It should be towards the negative y-axis. Why going to minus infinity? Okay, so imagine from here only that you are connecting a point from the second quadrant and the other point in the third quadrant. So obviously you will intersect the x-axis in between. And where do you intersect the x-axis? That is the critical frequency. Okay, so I'll just complete the shape. And this frequency refers to 0 plus. This frequency refers to 0 plus where it becomes This is a finite distance. This is x equal to minus of t1 plus t2. The asymptote again coming here. The asymptote again coming here. Asymptote coming here. And this is important. This is the critical frequency. This is omega c equal to 1 upon under root of t1 t2 and and the magnitude at this point, matlab magnitude means distance from origin, so that distance I am showing separately is t1 t2 divided by t1 plus t2. T1 plus t2, this is the asymptote x equal to minus of t1 plus t2. I have written here, let's not write it here. Okay, why minus of t1 plus t2? Because omega equal to 0 plus result hai na. Omega equal to 0 plus pe the x value, the y becomes minus infinity, but x is having a finite value minus of t1 plus t2. This is the polar plot. This is the polar plot. Now for 2-3 reasons, one is getting the correct chop, one is explaining you the critical frequency, and there's one more reason why I have solved this problem in detail without giving you any tricks, because this is going to be important. This is going to be important in the stability analysis once I start stability. And still we are just discussing the polar plots. First you have to be comfortable in sketching polar plot, and then we'll sketch Nyquist plot and then talk about stability. Okay. All right, everyone. Now make one more observation. I have to make you observe one more observation. Let us observe that. Yeah, I will hide my video, don't worry. Yes, guys. Now look at this, guys. Look at this. 1 upon s, 1 plus st. The yesterday's polar plot. That was entirely in the third quadrant. And now to this function. Now to this function. What is the change in both the functions? I am adding again one more pole. Open loop pole at s equal to minus 1 upon t2. Okay, here only 1 plus st and 1 plus st1 you can say. You can let me write it as 1 plus st and 1 plus st1, and now I have one more term 1 plus st2. That means I'm adding a open loop pole at minus 1 by t2. Minus 1 by t2. That is on the negative real axis. Adding a pole on the negative real axis. What is the effect on the polar plot? What is the effect on the polar plot? Last time we saw effect adding a pole at origin. Adding a pole at origin. So both 0 plus and infinity plus were rotated. Both 0 plus and infinity plus was rotated. This is already seen. I'm repeating that slide again. Just copied that slide again. This is done. Now we are focusing on this one. Now we are focusing on this plan. Okay. What is the effect? See, 0 plus is in the same direction towards negative y-axis. This is negative y. This is also in the negative y. So 0 plus is in the same direction. But if you look at the infinity plus which was closing, we were diving into the origin about negative x-axis, and now we are diving into the origin here along the positive y-axis. Okay, so that is a 90-degree shift in the clockwise direction. That is a 90-degree shift in the clockwise direction, but only to infinity plus. 0 plus is in the same direction. Okay, so addition of open loop pole at S equal to minus 1 by T, adding on the negative real axis, adding a pole on the negative real axis. Omega equal to infinity plus gets shifted by 90-degree clockwise, but 0 plus has the same direction, has the same position. 0 plus has the same direction. There is no change of the direction of 0 plus, but only there is the change of the direction of infinity plus. Is that okay? Is that okay, guys? So these are the two results, and apart from that, the effect of addition of open loop 0 will obviously be reversed. If I talk about 0 at origin, if I talk about 0 at origin, so both 0 plus and infinity plus will be shifted by 90-degree anti-clockwise. 90-degree anti-clockwise, reverse of the pole. And addition of open loop 0 at minus 1 by T, negative real axis, only infinity plus will shift 90-degree but anti-clockwise. अभी हम clockwise देख रहे हैं, with the 0 it becomes anti-clockwise. Omega equal to 0 plus, same direction. Same direction. So the rules for the zeros will reverse. So I am talking about two rules, that is the addition of pole or 0 at origin and addition of pole or 0 at minus 1 by T. Minus 1 by T. Clear? Origin or minus 1 by T. Origin or minus 1 by T. Alright? Okay. So if this is clear, can we have a sketch of this polar plot? Simply, without any calculation, can I have a sketch of this polar plot? अगर ये सारा points आपको clear है, can I have the sketch of the polar plots? One upon S, 1 plus ST1, 1 plus ST2, 1 plus ST3, 1 plus ST3. Yes. Yes, it is actually going to be in 3 quadrants. See, this is 1 plus up to 1 plus ST2. इसी में I need to add 1 plus ST3. Adding the pole on the negative real axis, only infinity plus will be affected. Right now, I'll show you here and sketch the answer there. Right now, it is intersecting. It is tangential to the positive x-axis. 90-degree clockwise shift करेंगे, so it should be coming tangential to the positive x-axis. It should be coming tangential to the positive x-axis, but this will remain same. This will remain as same. Okay, this will remain as same. So on the basis of this, I will sketch the plot. On the basis of this, I'll just sketch the plot without any calculation. Only talking about the shape. It closes here. Okay, this is 0 plus in the same direction. 0 plus is in the same direction. Infinity plus now closes along positive y-axis. Okay. This is done. Completed. Okay. That means if you solve it in detail, this should have 2 critical frequency, right? This should have 2 critical frequency. Okay. For shape that is not required, but I'm telling, if you solve it in detail, let me say this represents omega C1, one critical frequency, and this is another critical frequency, omega C2. मैंने क्या बोला? Critical frequency is any frequency where the polar plot intersects any coordinate axis. Okay. The 2 critical frequencies should come if you solve it in detail. Correct. Next one. Slight modification. Next one. Come on, solve this. Just I want the shape. That's it. 1 upon S square, 1 plus ST1, 1 plus ST2, 1 plus ST3. Come on, just I want the shape. Yes, Zayan. Previous one, it is correct. It is initially tangential to minus of T1 plus T2 plus T3. मतलब asymptote you are talking about, correct. So what is the change here with respect to the previous question? Question by question जा रहे हैं, ठीक है. Now 1 plus ST3 तक ये, but S square, ठीक है. S square. In the previous case, I added 1, ठीक है. I added 1 open loop pole. Previous question, I added one open loop pole at s equal to minus 1 by t3. And now in the same function, now I have added one open loop pole at origin s equal to 0. And because it is an open loop pole at origin, both the 0 plus and infinity plus, matlab in a sense, whole Nyquist plot, whole polar plot will be 90-degree rotated clockwise sense. Okay, so it was starting along parallel to the negative y-axis. Now it will start parallel to the negative x-axis after cutting the two cross corner frequency. Sorry, two critical frequency. It will come and close to the origin. This is infinity plus. This is going to represent 0 plus. These are my arrows. Okay, that's it. That's it. This is about 1 by s square, 1 plus st1, 1 plus st2, 1 plus st3. Now, for this next question, for that, first recall that yesterday I have solved GSHS equal to 1 upon 1 plus ST. One of the yesterday question that was lying entirely in the fourth quadrant. This was 0 plus and this was infinity plus. This is the yesterday's graph. And now I am giving you 1 upon 1 plus st1, 1 plus st2. So what is the polar plot for this? What is the polar plot for this function? Okay, again a addition of open loop pole at minus 1 by t on the negative real axis will shift only infinity plus and it will not affect 0 plus. It will shift infinity plus but not affecting 0 plus. Now, Gaurita, it is going to be in the fourth and third quadrant. Like this. 0 plus is same. 0 plus same. Look at infinity plus. It is coming along negative y-axis. So from negative y-axis, you have to shift 90-degree clockwise. 90-degree clockwise. That is towards the negative x-axis. That's it. One more. 1 plus st1, 1 plus st2, 1 plus st3. 0 plus will still be the same. 0 plus will still be the same. Infinity plus will again change. 0 plus will still be the same. Infinity plus will change. Sorry, this is 0 plus and infinity plus will make one more 90-degree clockwise rotation. It's going to come here. This is infinity plus. Yes, guys, second, third, fourth quadrant. Correct. All right. Now, Nihar, at 0 plus, it is exactly on the positive x-axis, not parallel to the positive x-axis. It is lying exactly on the positive real axis. Why it is lying? Because at omega equal to 0, GSHS is just 1 upon 1. It is finite. It is not tending towards infinity. Guys, time for your screenshots and then I'll tell you some more tricks now. This is one category of tricks, shifting. Okay, another category of tricks I'm introducing. So, ये तो yesterday class का था. Started today from here. Quickly take the screenshots. Quickly go for screenshots and then we'll start some more category of tricks. Other types of tricks मैं आपको बताता हूँ. For more simple sketching. Next one. Next. नेक्स्ट। यस शिवांश, अभी हम लोग रिलेट करके बना रहे हैं, फर्स्ट वन एंड देन द अदर। नाउ आई एम गोइंग टू गिव यू अनदर ट्रिक जहां पे आप डायरेक्टली भी बना सकेंगे। जस्ट वेट फॉर दैट। नेक्स्ट। 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 नेक्स्ट वन। नेक्स्ट। नेक्स्ट। नेक्स्ट वन, determination of critical frequency by the Euler's method. Next. 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 Okay, guys. Now I'm moving towards another set of tricks. And just like the polls, I'm giving you some questions as homework for the zeros. Okay, so I'm putting down some homeworks for you. Okay, take down the screenshots for these homeworks. It's number one. इनका भी स्क्रीनशॉट ले लीजिए. Number two, S square. GSHS equal to S, then S square. Then I have 1 plus ST. Then I have S into 1 plus ST. S into 1 plus ST1, 1 plus ST2. Okay. Now guys. Now guys. Some more tricks for quick sketching if only sketching is concerned. If only sketching is concerned. If stability, ठीक है, gain margin, face margin, उसके लिए तो हमें complete analysis के साथ plot करना होगा. But if only sketches are to be matched, then you can use this. So listen, suppose that you have the GSHS given to you as K into 1 plus ST1 1 plus st2 some zeros divided by s raised to the power n 1 plus sta 1 plus stb etc etc etc. Okay, so you have some zeros, you have some poles, okay, and you have some poles at origin. Okay, so here what is n? N is the number of open loop poles at origin. Okay, and then let p equal to number of open loop poles, total open loop poles including and excluding origin both, and z is equal to the number of open loop zeros. Z is equal to number of open loop zeros. Okay, now guys, what is the angle expression? Play with the angle. Play with the angle. Yesterday I was telling you about the starting and closing angle. I was telling you something about starting and closing angle trick. Okay, जो कई जगह अप्लाई करते हैं, but that goes somewhere wrong. Where it goes wrong, ठीक है, that no one knows. That student does not know. I'm going to tell you that also, because I've seen, maybe if you have used earlier, you know, but I have seen my past that some students learn the trick of closing and starting angle, but they don't know where to apply, where to not apply, so they apply blindly everywhere, and some questions may go wrong. Even some gate questions have gone wrong by that. So with precaution, I will tell you. So play with the angle. This trick is simply known as play with the angle. Okay, so what is the angle? Can I write down the angle expression? Yes, I have learned how to calculate the angle. So for the numerator, the angle will be positive only. So tan inverse, put down s equal to j omega directly. Put down s equal to j omega. So you have tan inverse omega t1, tan inverse omega t2, etc., etc., etc. Then come to the denominator. Denominator के लिए will apply, this will become s equal to j omega. So for j omega, the phase is 90 degree multiplied by n times, because there is n poles at origin. Then minus tan inverse omega ta minus tan inverse omega tb, etc., etc., etc. Okay, omega equal to 0 plus. Omega equal to 0 plus. What is the phase? What is the phase? See, all tan inverse 0 is 0. Whenever I put omega equal to 0 plus, all the tan inverse 0 term becomes 0, and the phase is just equal to minus 90 degree into n. Minus 90 degree into n. Okay. What about omega equal to infinity plus? Infinity plus पे all the tan inverse infinity becomes 90 degree. All the tan inverse infinity becomes 90 degree. So what is the phase? It is 90 plus 90 plus 90. How many times? How many may be the zeros? Okay. Minus 90 degree into n, that is fixed term. Then again minus 90, etc., etc., etc. So plus 90 for zeros and minus 90 it is coming for pole. Okay, plus 90 for 0, minus 90 for pole, and this is also minus 90 into n because of n poles. Finally this phase can be written as 90 degree into z. मैंने क्या बोला? Z is the number of open loop zeros. जितने भी zeros होंगे, how many may be the zeros, ठीक है, that many times plus 90 will come, ठीक है, and then plus minus 90 degree into pole, where this is also counted as a pole at origin. For every pole at origin, minus 90 is coming fixed, ठीक है, and but for other poles also which are not at origin, at infinity plus, that is giving 90 degree. So minus 90 into p. So this is written as minus 90 degree into p minus z. Minus 90 degree into p minus z. Okay, so remember this. So just remember this. Okay, so just remember my final way of sketching the polar plot with the case of angle. Just remember. Starting angle means omega equal to 0 plus p. I am going to call it as, in short, theta starting, and that is given by what formula? Minus 90 degree into n. That is given by the formula minus 90 degree into n, where n is the number of poles at origin. Already I have defined. Next, I define an angle known as diving angle. Diving angle, omega equal to infinity plus, because whatever polar plots you have seen till now, omega equal to infinity plus where you are diving into origin. When I say diving angle, diving से मेरा मतलब है you are diving into the origin. Diving means diving into the origin. Recall all of the polar plots that we have seen till now. At omega equal to infinity plus 1 upon infinity 0, magnitude 0 means origin. So you are diving into origin. So diving angle means at what angle you will dive into the origin. Okay, at what angle you will dive into the origin, I will write it as theta d, and that is just given by minus 90 degree into p minus z. Minus 90 degree into p minus z. Okay. Now, this is what commonly some students know, okay, and they commit mistakes in various questions. Precaution मैं आपको बोल देता हूँ. Okay. Now, if you follow this precaution also, then it will work absolutely fine. If you don't follow the precaution, then 70-80% will be right, others will be wrong. So, what is the precaution? What is the precaution? Number one. Don't apply the trick which I have told if n is equal to 0 and p is equal to z. If these two conditions are simultaneously true. ठीक है, मतलब there is no poles at origin and the total number of poles and zeros are same. Something like this, s plus 1 divided by s plus 2. One pole, 1 0, and there is no pole at origin. I am talking about both the conditions satisfying simultaneously. One pole, 1 0. Okay, and no pole at origin. What will happen? Why I am avoiding this is because as soon as you put omega equal to 0 plus, you get to answer as 1 by 2, and that is a finite answer. Okay, and also at infinity plus, if you solve, you are going to get the answer as 1. You are going to get the magnitude as 1. मतलब infinity plus पे this is not diving into origin. मैंने बोला I am talking about a diving angle, ठीक है? Diving, and it is diving into origin. So at omega equal to infinity plus, it will give you a finite magnitude. Numerator and denominator have the same degree. It will give you a finite angle, and it will not dive into the origin. So that is one precaution to be followed. If this is the case, solve by the classical method. Okay. Solve by the classical method. And second precaution, if pole or 0 is in RHP. ऐसा नहीं कि don't apply there, but there will be some change. If a pole or 0 is in RHP, then there will be some change. What is that change? Okay. If pole or 0 in RHP, there is no change in theta d. There will be no change in the diving angle. But theta st, the starting angle, will change. For 0, the theta st will change by plus 180 degree. मतलब whatever theta st you are finding here, उसमें plus st कर देंगे, plus 180 degree कर देंगे, and if there is a pole in the RHP, the theta starting will change by minus 180 degree. The theta st will change by minus 180 degree. Okay. Now, ऐसे समझ नहीं आएगा. Let us do few problems, then you will understand this. Okay, then you will understand this. Main point to remember is Okay, these are some basic derivations. Angle का मैंने बताया. Finally, how the angle has come? Don't look into that. What is the final angle? Starting angle minus 90 degree into n, and diving angle is minus 90 into p minus z. P minus z. Okay. Don't apply if p equal to z and n is equal to 0. Okay. And if there is a pole and 0 in RHP, change the starting angle. So right now I'm not taking any pole and 0 in RHP. वो later on लेते हैं. Let us take some simple examples now. ठीक है, ये उन केसेस, ये उन क्वेश्चंस के लिए वेयर ओनली शेप मैटर्स, लाइक एमसीक्यू क्वेश्चन एबीसीडी यू हैव टू मैच, वेयर ओनली शेप मैटर्स. ठीक है, बट इफ द स्टेबिलिटी एनालिसिस हैज टू बी डन इन डिटेल, देन वी विल हैव टू अप्लाई आवर क्लासिकल मेथड. ओके, चलिए लुक एट दिस. One by s, 1 plus st. 1 by s, 1 plus st. So guys, no need to expand any formula. Just tell me what is the starting angle and what is the diving angle for this. Starting angle and diving angle for this boliye. Quickly. Looking into the function, you will be able to say the starting angle. Starting angle is minus 90 degree into if it is multiple, so it will, see, suppose 2 poles. Zishan, suppose it is 2 poles, so twice of minus 180. If it is 1 pole and 1 0, so they will cancel also. There will be no change in the starting angle. Okay. Yeah, so minus 90 degree into n. N is the number of poles at origin. S power n, it is 1. So minus 90 degree. Theta d, diving angle. Diving angle is minus 90 degree into p minus z. 2 poles, total poles 2, zeros is nil. ठीक है, तो it is minus 180 degree. Okay, best by the knowledge of this, आपको क्या चाहिए? You are just concerned with the shape. Just concerned with the shape. Now look at this. Look at this, guys. Listen to me very carefully. Theta starting minus 90. That is why in the beginning yesterday I told you in the beginning yesterday ki what is the angle of every coordinate axis, so that now I am giving you the angle and you will decide the coordinate axis. Minus 90, negative y-axis. So the plot will start from negative y-axis. Okay. And theta dive, it will dive means dive into origin. Dive means dive into origin. At what angle? Minus 180. Minus 180 is negative x-axis. So start along the negative y-axis. Start along the negative y-axis and dive into the origin, touching. Dive into the origin, touching, tangential to the negative x-axis. Being tangential to the negative x-axis. That's it. Acha. Now, if you might have question, listen. Agar aapka koi bhi question hai, the first time thinking like that. Suppose if you have the question, ki why I am starting from infinity? Can't I start from a finite point? No, sir, because starting angle means what? Remember, starting matlab 0, omega 0. And if you put omega 0, it is there in the denominator, na? And if you put omega equal to 0, what is 1 by 0? Infinity. That is why start from infinity. That is why start from infinity. Start from infinity. Okay? That's it. Chaliye, let's take one more. We'll actually take few more. Next one. GSHS equal to, whatever we have done, I am repeating, then I will give you few more also. 1 upon s square, 1 plus st. 1 upon s square, 1 plus st. Theta starting and theta diving. Write down the angles. Nai Shubham, yesterday I did not teach at 1 minus 180n. That is wrong. Absolutely not. I cannot say that. You are relating some other thing maybe. Okay. Starting angle is given by, yes Shubham, please recheck. You may be referring to something else. Minus 180 degree into n. N is the number of poles at origin. This will come here. Minus 180 degree. Theta d, diving angle. Minus 90 degree into p minus z. P is 3 and z is 0. Okay, so minus 270 degree. Approximate, only shape, only the shape. So see, starting minus 180 matlab parallel to the negative x-axis. Okay, and this is minus 270. Minus 270 matlab positive y-axis. Positive y-axis. So you have to dive into the origin along positive y-axis and you have to start along the parallel to the negative x-axis. See, once again you can say starting matlab omega equal to 0, and for omega equal to 0, 1 upon 0 matlab infinity se start karna hai, not from a finite point. Infinity se start karke close along the positive y-axis. Done. That is my polar plot. If only the shape matters, this method is very good. With the precaution. Okay. By the theta starting and the theta diving angle. No, it's minus 180 only, na? It's minus 180, Anjana. One upon S, 1 plus ST1, 1 plus ST2. Yeah, Lasya. Chaliye, Lasya is putting up a doubt that is valid. I will answer to that also. Listen. Important to listen to that. Listen to this now. Yes, Shubham, once I go for screenshot, there I will explain. Just wait. Once I go for screenshot, na, वहाँ पे मैं आपको बताता हूँ. Look at this the doubt raised by Lasya. That's correct. How can it also start from the third quadrant? Listen. Can it also start from third quadrant? Listen, this doubt clarity is important. Otherwise, tricks will be misleading. So suppose you start from third quadrant, parallel to the x-axis. Now you have to go parallel to the negative x-axis. Okay. Parallel to the negative x-axis. So maybe this is also parallel to the negative x-axis. Why I don't choose this? Because if I choose this, and finally my diving angle has to be here only, na? Diving angle to minus 270 at origin. So I have to come and close along along positive y-axis. Okay. So why I have not taken this? Because if this is to be taken, there should be a critical frequency. And when do you get critical frequency? Phase is equal to minus 180. 2 times j omega terms, तो minus 180 minus tan inverse. मैं क्योंकि ये shortcut है तो मैं short में explain कर रहा हूँ. Because this is shortcut, I am explaining in short. Minus 180 minus tan inverse omega t. Now, critical frequency का method क्या था? Obtain the simplified expression of phase in the form of tan inverse. Obtain the simplified expression of phase in the form of tan inverse and then equate the numerator denominator to 0. अब यहाँ पे तो केवल एक ही tan inverse term है. ठीक है. There is no possibility of getting a critical frequency when there is only one tan inverse term. ठीक है. You will simplify when you have two or more than two, tan inverse A plus tan inverse B. That means there is no critical frequency possible. There is no critical frequency possible. Okay. So that is why this second possibility has been excluded now. Okay. I was talking about this one. Let's complete this as well. Theta starting. Yeah, if you have any doubts, it can be done. A quick check. Theta starting, it is minus 90 degree into n, and that is equal to, n is equal to 1 here. N is equal to just number of poles at origin. So minus 90 degree. Theta diving is minus 90 degree into P minus Z. 3 poles and again no zeros. So minus 270 degree. Okay. Theta diving is minus 270 degree. Theta starting is minus 90 degree. Now, पहले starting की बात करते हैं. What is theta starting? Theta starting minus 90 मतलब along negative y-axis. Listen, minus 90 मतलब negative y-axis से start करना है. Parallel to the negative y-axis from infinity. Why infinity? Starting is omega equal to 0 and 1 upon 0. 1 upon 0 will be infinity. Okay. And then you have to dive into the, diving means origin. dive into the origin at the angle minus 270. Minus 270 is positive y-axis. So obviously you will understand that you are coming from third quadrant to second quadrant. So you will intersect an axis in between. Otherwise you can't join them, na? Otherwise you can't join them. ये हो गया 0 plus. Okay, this is done. You have to intersect a coordinate axis, otherwise you will not be able to change the quadrant. You have to go from third quadrant to the second quadrant. Exactly the same shape we had taken while solving the classical problem. Okay, guys. Yes. Now, first precaution, both of them to be true. Both of them to be true. If both are true simultaneously, then it is the precaution. I told that time. Now, suppose I take another case. GSHS equal to 1 by S plus 2 S plus 3. Solve for this. Yes, Pawan, why not? Why you think negative? Yes, definitely you can get selected provided you pull your whole efforts. And already you're looking into your vision, your target batch students who have gone through 3-4 subjects till now. So how you are feeling with grade up? How confident about you? That you should also get the motivation ki yes. According to me, yes, definitely yes, you will be. There have students who have done in the past. It requires your time, it requires your dedication. वो आपको देना ही होगा. What is theta starting? What is theta starting here, guys? What is the theta starting here? 0 degree. It is minus 90 degree into 0. That is 0 degree. Okay, Pawan, no problem if you joined few days ago. Still, the time is left. Say 7 to 8 months is also sufficient. Minus 90 degree into 0. This is 0 degree. Okay. Theta will be 0 degree. But the point here is, point to be noted. Theta matlab, starting matlab 0 plus, and when you put 0, 1 upon 2 into 3, so you will have finite magnitude. So this time it will not start with infinity. This is the point you have to note. Okay, this is the point you have to note. If n is equal to 0, you have to start with finite magnitude. You have to start with finite magnitude. Correct. Finite magnitude. Now, theta diving, I will write down theta diving, that is minus 90 degree into 2 minus 0. 2 poles and no zeros. So this is minus 180 degree. Diving matlab diving into origin. Diving means diving into the origin, obviously. Okay. Now, starting is 0 degree. 0 degree means which axis, guys? 0 degree is positive x-axis. Positive x-axis with finite magnitude. That magnitude is 1 by 6, but don't write the magnitude. मैंने बोला ना, I want the curve. What magnitude does not matter, but it is finite. It is starting from the finite magnitude. Okay. And diving into the origin at along minus 180. Minus 180 matlab the negative x-axis. So being tangential to the negative x-axis, I take it here. Yes, definitely there is one critical frequency. That's it. Nice, Shashanka. It can't be 1, 2. I will explain the logic for that also. It cannot be 1 or 2. Okay, it is good to raise doubts. Listen, Shashanka again has raised a valid doubt. Why cannot be? Why can't I take it like this? इसमें क्या problem है? I'll sketch it with a different color. Yeah, that's what Shivansh I'm answering to. Why it can't be like this? That is what you are asking now. Why it can't be like this? Because this is also 0 degree and this is also coming parallel to the negative x-axis. Okay. For that, a very simple reason that I can play it. Agar thoda sa bhi doubts hai na. Okay. This trick is anyways very simple. This trick is taking how much time? Very much seconds. Okay. Seconds of time. No, Zion and Shubham, plus 180 minus 180 is one and the same thing. Plus 180 minus 180 is not a difference. It is one and the same thing. The reason is, okay, anyways, this trick is taking maybe just few seconds to sketch the Nyquist plot. ठीक है, तो अगर बहुत easily हो जा रहा है, doubt है, तो you can take one more calculation, just maybe few more seconds. What is the angle? Denominator के लिए minus tan inverse omega by 2 minus tan inverse omega by 3. ठीक है, and put a small omega, put a small value of omega. ठीक है, what will be the phase? Whatever small value you put, ठीक है, suppose you put minus 0.1 only, don't calculate. Exactly, Saurav Chatterjee, I'm going to comment on that. Minus 0.1 by 3. Don't calculate, but it is going to come up as negative. It is going to come up as negative. No need to use the calculator also. देख के ही समझ में आ रहा है, it is coming negative. So guys, listen now. Listen very carefully to this point. ठीक है. This is my point of 0 plus. ठीक है. Now as I increase the frequency slightly also, my angle is coming as negative. Negative means what rotation? Should it be clockwise or anti-clockwise? It should be a clockwise movement. Okay, so as you increase omega, it should represent a clockwise movement. Had it been positive, I will go anti-clockwise. Yes, Verma, it depends, exactly depends on critical frequency, but calculating critical frequency will take more time as compared to what I am telling. 100% answer is given by Verma. Actually, it depends on critical frequency. If you solve the critical frequency in detail, you will get that there is a critical frequency equal to minus 90 degree. Okay. There will be a critical frequency coming up as minus 90 degree. Okay. And that will make you clear that because I have to touch minus 90, matlab I am going from down. Okay. But critical frequency again will take a little more time. यहाँ पे no calculation, just check angle negative है. Okay, negative matlab go clockwise. If it was positive, I will go anti-clockwise. Like that we can relate. Is that clear now? Is that clear now? Now can you try this one? Sketch the polar plot for GSHS equal to S plus 1 by S square, S plus 2, S plus 3. Yes guys, say can we try this one or not now? Okay, so I hope it might have been completed by this time. So what is the theta starting? What is the theta starting? It is minus 90 degree into 2 minus 180 degree. Theta diving minus 90 degree, 4 poles, 1, 2, 3, 4, minus 1, 0, so minus 270 degree. Okay, so minus 180 and minus 270. Okay, correct. So let us have a plot on the basis of this approximate shape. Now starting minus 180 matlab parallel to the negative x-axis and closing diving is minus 270. Minus 270 is positive y-axis. Okay, positive y-axis. It is along positive y-axis. And okay, the other one is negative parallel to the negative x-axis, and this is positive y-axis. Negative x and positive y. Okay, negative x and positive y. Now positive y axis पे आना तो है, but negative x where? मतलब from where I should start? Should I start from this quadrant itself or should I start from this quadrant itself? Okay, so see guys, once again there are two methods. You can see that here you can see that face is so many tan inverse term, tan inverse omega by 1 minus 180 degree minus tan inverse omega by 2 minus tan inverse omega by 3. So you will involve into simplification of tan inverse. And when does the critical frequency arises? When you simplify the tan inverse by using tan inverse A plus tan inverse B minus tan inverse C and write down the simplified expression. So there is the critical frequency possibility coming up, and critical frequency को show करने के लिए start from the third quadrant. It is going to be start from the third quadrant and join like this. This is 0 plus starting with the third quadrant and closing in the second quadrant. That is approximately the shape, the polar plot. Okay. After some time, we are going to convert it into the Nyquist plot also. Okay, done? Chaliye. Next one. Next one. Say me the starting angle and the diving angle here. Just comment on the starting angle and diving angle here. Just say the starting and the diving angle here. Just say the starting angle and the diving angle here. Yes, Zayan. Okay. So not everyone correct with the starting angle. Not everyone correct with the starting angle. Observe that. मैंने precautions पहले ही बता दिया है आपको. Not following the precaution. Note that S is equal to 2 is open loop 0 in RHP. In RHP. Okay. So what is the theta starting angle? It is given by minus 90 degree into n added with 180 degree. Okay. Minus 90 degree into n plus 180 degree. Okay. So that is minus 90 degree into 2 plus 180 degree, and that is actually 0 degree. That is actually 0 degree. Okay, that is actually 0 degree. Now theta diving, what is the theta diving? That is minus 90. The pole of 0 and the RHP does not affect the diving angle. The 4 poles and 1 0, so theta diving is minus 270 degree. Minus 270 degree. 0 and minus 270. Okay, 0 and minus 270 degree. Okay. Yes, so that's the final result. And now I am going to give you the plot. Now what is the plot? Starting angle is 0 degree. 0 degree matlab parallel to the x-axis. parallel to the x-axis, and closing, diving is where? Diving is minus 270 degree. Diving is at minus 270 degree. Minus 270 degree matlab positive y-axis. Positive y-axis. Diving is here, positive y-axis. Positive y-axis. So it's going to come up as a shape of the form like this. Infinity plus 0 plus. All right. Yes, 432. 432. If you again are getting any doubt, ki why below, why not from the above? Okay. Yes, Ian. If I'm commenting on that only, if you start from first, if you think that you can start from first, the same thing I can say, same thing. This is omega equal to 0 plus, and just change the frequency from 0 plus to any small frequency 0.1 and see what is the result of the phase. It will come up as negative. For example, omega equal to 0.1, check the phase of this. Check the phase of this. It will come up as negative. Okay, you can check it. I am giving you the hint. It will come up as negative, and negative matlab again clockwise. Clockwise. Yes. Okay. So like that you can check Lasya, Deepa and Zion. Fine. 0.1, take any small frequency 0.1, you will get it as negative. Get it as negative. Okay. So sometimes with the trick, if you have little confusion, a small calculation is sufficient to eliminate the doubt. If it is MCQ question, you can use this. All right. Chaliye guys, quick screenshots up to this point and then we move forward. Yeah, starting from here. We had taken up to this one. Yeah. Quickly take the screenshots here. Yes, mostly Dinesh ऐसा ही होता है, correct. Shubham, to say how many critical frequency actually, first I will comment to this, Shubham. You were asking about this, otherwise I'll move this. Yes, definitely. I am telling it for gate question only. If it is a conventional question, then these tricks are not valid. Then you can't apply the tricks. You have to show the classical problems. But for gate and MCQ questions, I am only telling this. Yes. Yes, Dinesh. What I was telling is, look at this. This is j omega. S equal to j omega. J omega coming n times. And what is the phase of j omega? Shubham, you are asking me. What is the phase of just, if I write 1 by j omega, the phase is 0 minus 90. And j omega into n times. So minus 90, minus 90, minus 90 will come n times. That is why I write minus 90 into n. Okay, you are asking me, well, Shubham, so I have replied to you. Minus 90 into n. And then if I put omega 0, starting angle, so all tan inverse 0 is 0. That is why the phase left is only minus 90 degree into n. Okay. Yeah, guys. Next one. So how to critical frequency, you can say by shortcut, it depends on the joining, which point to which point you have to go, and to join them, obviously I am intersecting two axes. That is why two critical frequency. Okay, this is the final slide now. This is what you have to remember. Starting angle, diving angle with two precautions. Starting angle, diving angle. Starting angle and diving angle formula. And then with two precautions. Next screenshot. Yes, Shubham, that is what I was telling to Zion and others as well. You can check the angle at omega equal to very small value 0.1. You will get the angle as negative. Matlab clockwise you have to move. Negative matlab go towards the clockwise movement. Start in the clockwise direction. I'll hide my view. Sorry, I've hide my view. Next one. Next. 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 No, but Soumya, that will violate the clockwise movement then. That will violate the clockwise movement. Yeah, guys, now come back. No, Amit, it's absolutely fine. It is absolutely fine. Even we can solve by the traditional method also, it is going to come up as this only. Whatever question I've given as a trick will come up as the conventional method also will show you the same result. The conventional method will show you the same question. Okay. Sketch the Nyquist plot for GSHS equal to K by S 1 plus 10S. Okay. You can try it by the conventional method also, Amit. It will come up as same only. Okay. K by S 1 plus 10S. Now coming for the Nyquist plot, guys. Coming to the Nyquist plot. And determine the range of K for stability. Range of K for stability. Okay. Range of K for stability. No, it will cut. It will cut. 100% I'm telling now. How it is coming, what is the plot coming, better to share me in the doubt box. Okay. Yeah, diving means diving into the origin. I specified there also. Diving means I'm diving into the origin. Okay. Diving into the origin. Yeah, Amit, better to share me the screenshot of that. I will see how it is. But I have tried by the regular method also, and then only I bring such questions. Okay. Unless and until that is matching with the conventional question, I will not bring that question as a trick also. So the trick should be applicable everywhere. Okay. Sketch the Nyquist plot for GSHS equal to K by S 1 plus 10S. K by S 1 plus 10S and determine the range of K for stability. Determine the range of K for stability. Okay. So now this is a type of function that we have already discussed. K into 1 by S 1 plus 10S. 1 plus 10S. Okay. K by S 1 plus 10S. Okay. 1 plus 10S. Now if that is the case, guys, see, already we have seen the polar plot for this. Already we have seen the polar plot for this. Okay. Now, let me first take the polar plot because we have already learned that. Look at this. K into 1 by S, 1 plus 10S. What is the polar plot for? What is the polar plot for 1 upon S, 1 plus ST? This form is nothing but 1 by S, 1 plus ST. So we have taken the polar plot. Basically, I am taking first 2-3 problems where I have considered the polar plot and then now going to convert into the Nyquist plot. Polar plot for 1 upon 1 plus 1 upon S, 1 plus ST. Remember, this was the polar plot. Okay, this is the 0 plus point. This is the 0 plus point. This is the infinity plus point. I'm not repeating the polar plot steps again. It is already solved. 0 plus and infinity plus point. This distance, if you remember, not necessary, but if you just remember, this distance was equal to t. Okay. So now only thing is, because it is multiplied by k, this distance is going to become k into t. Because the transfer function is multiplied by k, so all the magnitudes will be multiplied by k. So k into t, and the value of t is 10. The value of t is equal to 10. So it is 10k. Okay, it is 10k. Now that is the polar plot complete. Now listen everyone. After the polar plot, what is the second step? What is the second step after the polar plot? I'm just repeating it for a reason. I'll show you the better picture. Just a second. What was the second step? Can you repeat? Can you say that? Then we'll complete the sketch. What is the second step? Yes, guys, correct. The second step was take the polar plot for the negative values of omega, and for that, what did I say? You have to take the mirror image. So this is 0 plus. This was marked as 10k. This is infinity plus. Okay, and now I take the mirror image. Mirror image about what? Mirror image about the x-axis. Step number 2. So I take the mirror image of this, replica of this. Just take the mirror image of this. Okay. And then do what? Achha, if this is the mirror image, so 0 plus point is converted to 0 minus, and infinity plus is converted to infinity minus, negative values. Okay. And then now do what? Okay, step number 1, step number 2. Now step number 3 was closing. Step number 1, polar plot. Step number 2, mirror image. Step number 3 was closing from minus J0 to plus J0. And what was the closing angle? Through an angle equal to n pi in the clockwise sense. Through an angle of n pi in the clockwise sense. Correct? Through an angle of n pi in the clockwise sense. So 0 minus to 0 plus. Now obviously you will observe that 0 minus is where? Just look at this. 0 minus is along the positive y-axis and 0 plus is along the negative y-axis. So how will you join positive y to negative y? Obviously a semicircle, 180-degree rotation will come. So look at this. I start from here and I take a circle of infinity radius and come and join that circle to the 0 plus point. This is the joining from 0 minus to 0 plus. And after completing the joining, see n pi, n is equal to 1 here. For this question, n is equal to 1. N is equal to number of poles of GSHs at origin. So n is equal to 1 only. Okay, so here it is n equal to 1. So the angle is pi in the clockwise. So I followed the clockwise rotation in the clockwise. Now sketch the arrows, and arrows will be taken for all increasing values of omega. That is infinity minus to 0 minus, 0 minus to 0 plus 0 minus to 0 plus 0 plus to infinity plus 0 plus to infinity plus, right? This is the direction of arrows. Now, where is my important point? Where is my altogether important point? This is just the sketch. Now, question also said, do the stability analysis. Do the stability analysis. Just go for the stability analysis of this. And what is the stability analysis? That is, now you have to recall your yesterday's discussion. What did we learn for the stability formula from the Nyquist plot? That whole complete derivation. N equal to P plus minus Z plus. Okay. N is equal to P plus minus Z plus. Right. What is N? What is P plus? What is Z plus? N is equal to number of encirclements of minus 1 comma 0. Minus 1 comma 0, which lies on the x-axis, negative x-axis. Is there any encirclement? Nahi. Here the minus 1 comma 0. Here for this question, minus 1 comma 0 is outside the plot. It is outside the plot. So what is the value of n? 0. No encirclement. Okay. What is the value of P plus? P plus क्या define किया था? P plus means number of poles of GSHS, that is open loop poles in RHP. In RHP. So let us go back to the question slide. What are the poles? It is 0 and minus 1 by 10. ठीक है, so what is the value of P plus is 0. There is no pole in the RHP. No pole in the RHP. So P plus is 0. Okay, so apply 0 is equal to 0 minus Z plus. So Z plus is equal to 0 always. ठीक है, Z plus equal to 0 for all k, and that means the system is Z plus equal to 0 means the system is stable. Stability के लिए यही चाहिए था ना. What did we want for stability? That for stability Z plus should be 0, and here it is the Z plus equal to 0. Z plus is what? Number of roots of characteristic equation. And if there is no root of characteristic equation on RHP, the system is stable. The system is stable. Okay, yes, Shivan, still now we were discussing only polar plot. Now this is the complete Nyquist plot question. This is the complete Nyquist plot question. Let's take one more to understand, have a better understanding. Let's take one more. Take the screenshot of this question first. Let's take one more to understand in a better manner. Screenshot for this question, please take it. Number 1. Next. Yeah, sorry, I'll hide my view. Take the screenshot now. Next. Next. Okay. Now, next question, guys. Sketch the Nyquist plot for GSHS equal to K by S 1 plus S by 2, 1 plus S by 3. GSHS equal to K by S 1 plus S by 2, 1 plus S by 3. Okay. Now, what are the poles of this function? S is equal to 0, minus 2, minus 3 means there is no pole in the RHP. First of all, I'm writing the P plus value. The pole is at origin or LHP, but there is no pole in the RHP. P plus is equal to 0. The P plus is equal to 0. Okay. Next. Now, what is the polar plot for this? We all know. What is the polar plot? It is of the form. What is the type of the question? What is the form of the question? It is 1 by S 1 by s, 1 plus st1, 1 plus st2. Remember, that was the form that we have solved. Okay, in this form we get a critical frequency given by 1 upon root t1 t2, 1 upon root t1 t2, and that is equal to 1 upon, what is t1 t2 here? No, Shashanka, not the correct analysis. 1 upon root t1 t2. What is t1 and t2? 1 upon t1 is half and t2 is, the other one is 1 3. So 1 upon 1 by root 6, final answer root 6. Final answer root 6. Okay. And I'm using the result that we have solved at omega equal to omega c equal to root 6. What was the magnitude? I gave you the formula for magnitude there. You can just refer to your notes. T1, T2 divided by T1 plus T2. It will be multiplied by K because there is, in that question, we have taken the numerator as 1, but now the numerator is multiplied by K. So the gain is multiplied by K. It is K into T1, T2 divided by T1 plus T2. So this will be equal to K 1 by 2 into 1 by 3 divided by 1 by 2 plus 1 by 3 multiplying by 6. I get K divided by 5. K divided by 5 at omega equal to omega c equal to root 6. Now let us complete the plot. These are the required calculations done. Let us complete the plot. And an important question is, do the stability analysis. Do the stability analysis. Now guys, understand the Nyquist plot. First I take the polar plot, and as we have seen the polar plot, I will just repeat that polar plot as already discussed. As already discussed, I'll just repeat that polar plot. This is the 0 plus point. This is the 0 plus point. This is infinity plus, and this is what? This is your critical frequency. This is the critical frequency, omega c equal to root 6. Root 6. That is the critical frequency. Root 6, where I cut any coordinate axis. Okay. What is the magnitude at critical frequency? That is given by K by 5. Okay. I will highlight this later. First, let me complete the Nyquist plot. This is just the polar plot, guys. To complete the Nyquist plot, what will I do? I will take the mirror image of this. I will just take the mirror image of this. Okay. I will just take the mirror image of this about the x-axis. So just taken the mirror image. This becomes 0 minus, this is 0 plus. After taking the mirror image, join the 0 minus to 0 plus. See, what is the value of n? This will tell you that the value of n is 1. Number of poles of GSHS at origin is 1. Okay. Yeah, Shivan, square root of 6 is a positive number, but I am not telling that this point is root 6. This point is obtained for omega is root 6. Omega का कोई axis नहीं है यहाँ पे. Omega we are just highlighting. That is why we write omega separately. Okay. Yeah, I'm telling n equal to 1. So because n equal to 1, so what is the closing angle? Closing angle is given by n pi, and that is equal to pi is always in clockwise. N pi in always clockwise direction. Okay. So from 0 minus, you come and join the 0 plus by pi 180 degree clockwise. So this is the clockwise. Just mark the arrow separately. Okay. This is the closing of the Nyquist plot. I will complete the Nyquist plot by marking the arrows. Arrows will start from, just a second. This will be the mirror image of infinity plus. So this is infinity minus. And now let us mark the arrows. Arrows will start from infinity minus. It will go to first 0 minus. 0 minus to 0 plus. 0 minus to 0 plus. 0 plus say infinity plus. 0 plus to infinity plus. Okay. This is the Nyquist plot complete. This is the Nyquist plot completed for this given transfer function. Completed for the given transfer function, right? Now, stability analysis. Question also says range of k for stability. Stability analysis is n equal to p plus minus z plus. We have originally मैंने ही आपको बता दिया कि p plus is 0, so n is minus z plus. So z plus is equal to minus n, and that depends on the number of encirclements of the point minus 1 comma 0. Okay, so for stability we need to check the number of encirclement of the point minus 1 comma 0. So where is minus 1 comma 0? Where is minus 1 comma 0? To write down minus 1 comma 0, first I have to show you what is this magnitude. This is the critical frequency and this magnitude. Writing it separately, वहीं पे note करूँगा तो hosh posh हो जाएगा. Just writing it separately. What is this magnitude? This magnitude at the critical frequency is k by 5. So this is k by 5. Okay. So if the k is suppose 10, so if the k is suppose 10, 10 by 5 is 2 and 2 is greater than 1. So minus 1 comma 0 can be inside. Okay. Or if the k is suppose 1, 1 upon 5 is less than 1. So k by 5 may be, so minus 1 comma 0 may be outside or may be inside. It may be outside or it may be inside. Suppose I call this as case number 1 as case number 2. Okay, case number 1 or case number 2. Okay. For the case 1 that I have highlighted in the plot, minus 1 comma 0 is outside. And how it can be outside? What is the distance of minus 1 comma 0 with respect to the origin? That is 1 unit. Minus 1 comma 0 minus because of negative x-axis, the distance wise it is equal to 1. So this is outside if the distance 1 is greater than the distance at the critical frequency point, that is omega by 5. That means omega is less than 5. And if it is outside, so what will be the number of encirclements? Obviously 0. Outside matlab number of encirclement is 0. So what is z plus? It is minus n, as I've shown you in the previous calculation. Z plus is minus n, so that is also equal to 0, and hence the system is stable. Okay. The system is hence stable. Okay. Next. Just a second. I need to create a slide. Next. Case number 2. Case number 2, which I have shown you on the plot. See, case number 2, minus 1 comma 0 is inside. Minus 1 comma 0 is inside. And how it can be inside, first of all? How it can be inside if the distance 1 is less than the distance at the critical frequency, that is k by 5. So that leads to the conclusion k is greater than 5. And if it is inside, what is the number of encirclement? See, I will show you the number of encirclement. Now guys, with full concentration, just follow my pointer. Okay, number of encirclement. This is minus 1 comma 0 if it is inside. So look at this. This is one small loop. This is one inner loop going on. What direction my pointer is moving? Just observe. What is the direction my pointer is moving? It is clockwise. Okay. My pointer is moving in the clockwise direction. Tick. Now next. Look at the next one. Take from here. Outer loop and outer loop. Just follow. Outer loop. Also one more circle completed. I come back to the same point. So it is being also encircled by the outer loop, and again what is the direction of the movement of the outer loop is clock. Direction of the movement of the outer loop is again clock. Okay, so I will write down the results here. N is equal to two encirclements but in clockwise sense. So actually, what is the value of n? Clockwise, I have told negative. Anti-clockwise, positive. I have told you yesterday. So it is 2 encirclement in clockwise, so n equal to -2. Now apply in the formula. What is z plus? What I have told you, z plus is minus n. Okay, z plus is minus n. The z plus is equal to minus of -2, that is plus 2. That means 2 RHP roots of what? Z plus is the roots of characteristic equation, and hence system is unstable. Question tha, what is the range of K for stability? What is the range of K for stability? So system is stable for the case number 1, that is for K less than 5. For K less than 5, the case number 1, K less than 5. The system is stable for K less than 5. That is the answer. That is the answer. Okay. Now with this, I will tell you two categories. See, this I have taken this complete question. I have taken this complete question for a reason that, first of all, okay, yeah, k equal to 5 पे क्या होगा? That is marginally stable. Just wait, I will comment on it later. When the Nyquist plot just crosses the -1, 0 point, marginally stable case, okay, now xi and z plus cannot be negative. Impossible. आएगा ही नहीं कोई Nyquist plot में. It is impossible. Okay, Shashanka, I will comment on that marginally stable once I start the gain and phase margin. I will comment on that when it crosses the -1, 0 point. Now listen everyone. The first category of question is sketching the polar plot of the Nyquist plot. Okay, so we complete the Nyquist plot. Okay, we complete the Nyquist plot. Okay. Apart from that, ठीक है, आप सोचोगे कि what is the range of K for stability? You will say that, sir, why can't I find by the Raut-Hurwitz? Yes, you can. अगर क्वेश्चन सिर्फ इतना ही, if the question says given GSHS and find the range of K for stability, no need to sketch the plot. This is not required. You can directly solve by the Raut-Hurwitz. You can directly solve by the Raut-Hurwitz. ठीक है, but still, why Nyquist is important, that we will see in the upcoming class when I introduce the gain and phase margin. And apart from that, there is a second category of question in gate that also I will take. I will take the proper gate question also. There have been question in gate given this Nyquist plot. Given this Nyquist plot, इस Nyquist plot को observe कीजिए, and by observing directly given this Nyquist plot with all the values and looking into the Nyquist plot, can you determine the range of K for stability? That is a question in gate. That is a separate question. They are not asking you to sketch the Nyquist plot. Given the Nyquist plot, analyze the Nyquist plot and determine the stability. Comment on stability. So that also should be known to you. And from the Nyquist plot, how do you comment on the stability? Is the n equal to p plus minus z plus formula, right? N is equal to p plus minus z plus. Now time for you to take the screenshots. Take the screenshots quickly. Take the screenshots and quickly first. Next one. Next. Next one. Next. Next. Next one. Okay, guys. Now I'm sketching a Nyquist plot on quick basis. Okay, on quick basis. चलिए, let me remove the stability here. Let's not. Let me first only point out this one. Sketch the Nyquist plot for GSHS equal to 10s plus 3 upon ss minus 1 on a quick basis. On a quick basis. For quick basis means no need for detailed calculation. It is just about starting angle and closing angle. Starting angle and the diving angle. Take the starting angle and the diving angle. What is the starting angle and what is the diving angle? Okay, again with the precautions. Okay, quickly. Okay, quickly by theta st and theta diving. Just approximately I want. Approximately. No need for the detailed calculation. No need for the detailed calculation. So see. Again, please note that before I start any calculation, S is equal to 1 is an open loop pole here. S equal to 1 is an open loop pole here. S equal to 1 is an open loop pole here. Okay. That is in the RHP. That is in the RHP. So theta st has to be taken carefully. What is theta st? What is theta st? It is minus 90 degree into n, and because a pole has come, because of the 0 it was plus 180, and now because a pole has come it is minus 180. I told you. No? And what is the value of n? It is just 1. So it is minus 270 degree. Theta diving is given by no change on the theta diving even if the pole and 0 is RHP. So n minus 1 p minus z kitna hoga? 2 poles and 1 zeros. So it is minus 90 degree into 2 minus 1, and that is just minus 90 degree. That is just minus 90 degree. Even after detailed calculations, aapka plot wahi aayega that we will sketch by the shortcut. Okay, so plot starts from where and goes to where? Can you say? Which quadrant to which quadrant? Can you say? Only thing is polar plot आप shortcut से बना लेंगे. Nyquist plot के लिए step number 2 and 3 will complete. Diving angle is minus 90 degree. Diving angle is minus 90 degree. Okay. Yes, it is going to be actually. It is going to be नहीं fourth नहीं आएगा. Fourth नहीं आएगा. Fourth नहीं आएगा. No. It will not be fourth. See, if you are getting fourth, so better I will explain you one thing. What is omega c? Can you calculate omega c? It is a simple activity. Can you calculate omega c? See, by the knowledge of this much, I will tell you the shape. It's going to be. And for detail, for getting your doubts more clear, I will tell you the exact analysis also. See, it's going to be something like this. It is going to be, first I will sketch it approximately. Minus 90 is negative y-axis. Minus 270 is positive y-axis. So it will be from positive y-axis to this point. It's going to be like this. This is going to be the starting point 0 plus. This is going to be the ending point infinity plus. This will be your polar plot. Okay. Once again I say how to confirm with the quadrant. You can check the critical frequency or you can check the angle at very small frequency. Okay. What is the phase here? Let us write down the phase. Guys, let us write down the phase. What is Gj omega Hj omega? What is Gj omega Hj omega? It is 10 into S plus 3. S plus 3 means 3 plus j omega divided by S, that is j omega, into S minus 1, matlab minus 1 plus S, minus 1 plus j omega. Okay, minus 1 plus j omega. So what is the phase expression? Now you have to be little careful in the phase calculation. ठीक है, approximately polar plot मैंने पहले shortcut से भी बना दिया, and then now looking into this. Phase numerator tan inverse omega by 3. ठीक है, denominator j omega, so 90 degree. Again denominator term, so tan inverse y by x, so omega upon minus 1, and you have to apply the second quadrant formula, otherwise you will get the answers as wrong. So this phase is tan inverse omega by 3 minus 90 minus 180 degree minus tan inverse omega by 1. Okay. So upon simplification, what is the phase? Minus 90 minus 180 is minus 270 plus tan inverse omega by 3, and this is also minus minus plus tan inverse omega. Okay. Yes, Sandulya, Samya correct. Sandula Samya correct. Okay, this is the phase. So this phase is equal to minus 270. For critical frequency, you have to simplify the phase. So plus tan inverse omega by 3 plus omega a plus b upon 1 minus ab. Okay, so that is actually equal to minus 270 degree plus tan inverse of multiplying by 3, you get 4 omega upon 3 minus omega square. Quickly equate the denominator to 0. Numerator को 0 से equate करके no use, you will get only omega equal to 0. Okay, I told take between 0 and infinity. Denominator 0 is already the starting frequency that is considered. So you get omega c equal to root 3. Omega c equal to root 3. Okay, and then what is the phase? Phase is minus 270 plus tan inverse 4 root 3 divided by 0. Okay, so this is equal to how much? Tan inverse infinity, so minus 270 plus 90, so will become minus 180. यहाँ से clear हो गया? यहाँ से clear हो गया? I will write it again. Wait. Phase is equal to minus 270 plus tan inverse infinity, that is 90, so it is minus 180. So from here it is now clear that you are going to intersect the negative real axis. You are going to intersect the negative real axis. That is why this the second and third quadrant, not the first and fourth, not the first and fourth. और how else, और किस तरीके से आप चेक कर सकते हो quadrant? I told take any small omega, then also you will be getting that same result, जैसा मैंने आपको earlier बताया है. Now let me complete this. Let us sketch the complete now. This is just the polar plot now. Let us complete the Nyquist plot. Let us just complete it. First, that same polar plot which I have already sketched, this one which I have sketched already. Critical frequency आ गया है. This is known as the critical frequency. Critical frequency negative x-axis पे, that also I have proved it to you. So I will just copy this polar plot first. Copy this polar plot. Okay, I'll just copy this polar plot. And then take the mirror image. This is infinity plus the diving angle. This is 0 plus. And now take the mirror image. Completing the Nyquist plot, guys. This is just the polar plot. And now take the mirror image of this. Okay. Just taking the mirror image of this. This represents 0 minus. This represents 0 minus. This is infinity minus. Now, what is the closing angle? What is the closing angle? Oh, just a second. Just a second, I'll have to add a slide. What is the closing angle? It is given by n pi. Okay. In the clockwise direction, n is equal to again 1. N is again equal to 1. GSHS आपको known है. ठीक है. Number of poles at origin s power 1 है. So n is equal to 1. So pi in the clockwise. Pi in clockwise. 180 degree clockwise. Closing matlab closing from 0 minus to 0 plus. Now please note here very carefully कि 0 minus is below actually. Okay, and 0 plus is above. Okay, so but you have to start from 0 minus to 0 plus in the clockwise. So how will you show the closing? How will you show the closing? So it is in the clockwise. You can't like this. This is anti-clock. You have to go only in the clock. Sorry, that is erased. Just a second. Eraser is highly sensitive now. Okay, yeah. So come back to the diagram. Yes, it is going to be 0 minus to 0 plus in the clockwise in this manner, in the direction of clock. For closing angle, didn't understand your point, Nihar. Can you please elaborate? Didn't understand your point. Now guys, sketching the arrows, I will hide my view. From infinity minus, okay, this is infinity minus going to 0 minus, 0 minus to 0 plus. This is the clockwise movement. Now follow the arrow. Then 0 plus to infinity plus. That's it. That is the complete Nyquist plot. Guys, I'm trying to take variety of examples so that every case you learn something. Now, Shashankar, you're talking about stability, but for stability, we'll have to check the number of encirclement of -1, 0, and that can only be done. I will write down this frequency. This is the critical frequency, omega c equal to √3. Will be √3. Yes, now whether it is in the small circle or not, Zion, that also we can be able to figure out. Okay guys, the Nyquist plot is done, but if you are interested in knowing the stability, come back to the critical frequency again. Guys. Okay, at the critical frequency, the phase is -180 degree, negative real axis, that is correct. But what is the magnitude? At omega equal to omega c, which is √3, can I calculate the magnitude? This will, yeah, Vishnu, I'm telling the direction of arrow, matlab starting, increasing value of omega, -infinity to +infinity, trace. So magnitude, can I not take the magnitude? Yes, I can take the magnitude. See, this is 10. Magnitude is equal to 10. Okay. Actually, the function is 10, 3 plus j omega divided by j omega into -1 plus j omega. So 3 plus j omega के लिए complex number का magnitude you will write 3 plus √3 square. Root over 3 square plus √3 square divided by omega. J omega magnitude is omega √3 under root of 1 square plus √3 square. Like that. So it is 10. Let me take the under root terms all together. 3 square is 9. 9 plus 3. 9 plus 3 is 12. Divided by √3 and divided by 1 plus √3 square 4. So it is just coming up as 10, guys. 12 and 12 cancel. It is just coming up as 10. Okay, so it is not 10 by √3. It is not 5 √2. It is exactly equal to 10. Okay. Magnitude for this function at omega equal to root 3. So if the magnitude is root 10, so that also is highlighted. Magnitude matlab, magnitude at critical frequency, I am telling, at this point. Okay, so distance of this point from origin is 10 units. So now you will be able to say where is minus 1 comma 0. Obviously 1 is much less than 10. So where is minus 1 comma 0? It is inside. It is inside. Minus 1 comma 0 is inside. Okay. Let me complete the stability analysis also. Stability analysis. Okay. Let me complete the stability analysis also. Okay. Yes, guys. Stability analysis. Clearly seen that minus 1 comma 0 is inside the inner loop. Actually, there are two loops running. It is inside the inner loop. This one, the small loop, the small loop, the small circle. What is the number of encirclement? What is the number of encirclement? Okay. No, guys, still you are missing something. Still, Shashanka, you are missing something. Look at this. Inner circle, there is only one rotation. There is only one rotation. That is in the anti-clockwise. That is in the anti-clockwise. Look at my pointer. It is anti-clockwise, na? It is anti-clockwise. Okay. The outer loop does not make. See, outer loop is also there. This is the outer loop. Follow my outer loop. But that is not encircling the minus 1 comma 0. That is not encircling the minus 1 comma 0. Okay, so I will write down here n is equal to, you have one encirclement, okay, in the anti-clockwise sense by the inner loop, okay, and you have no encirclement. I will write down the all details, and you have no encirclement by the outer loop. Outer loop is not encircling. Okay, so what is the value of n? One encirclement anti-clockwise, so it is plus 1. It is plus 1. And then apply the formula n equal to p plus minus z plus. But what is p plus? n to 1 hai. Number of encirclement does not ensure ki unstable hoga. You have to look into p plus also. What is p plus? What is p plus? GSHS is 10 s plus 3 divide by s minus 1. Look at the question. And what are the poles? It is at 0 and plus 1. There is one pole of GS. What is P plus? Poles of GSHS and RHP. So P plus is equal to 1 and hence the system is stable because Z plus is 0. Otherwise तो क्या हो जाएगा ना, Z plus is minus 1 and that is impossible. Z plus will be minimum 0. कोई counting negative नहीं हो सकता. Z plus is number of something, number of poles. It will either be no poles or 1, 2, 3 poles. What is the meaning of that minus 2 poles lie there? Not possible ना. तो Z plus तो negative हो ही नहीं सकता. It is not possible that Z plus can be negative. So final answer, Z plus is 0 and hence you have a stable system. If any doubt, you can verify by Routh-Hurwitz. If any doubt, you can verify by Routh-Hurwitz. Chaliye, quickly verify. What is the characteristic equation? It will just take very much seconds. 1 plus 10 s plus 3 by s minus 1 equal to 0. S square minus s plus 10s plus 3, sorry, plus 30 equal to 0. S square plus 9s plus 30. Second order है, no need for Routh-Hurwitz also यार. Second order है, Routh-Hurwitz भी नहीं चाहिए. पता चल गया zeta positive है and that is why system stable. That's it. Routh-Hurwitz also not required because it is second order. Verified easily. Stable hai. That is what the answer is given by the Nyquist analysis also. Stable, stable, stable. For second order, it is just coefficient sign or just the zeta sign. All terms with the same sign. Correct, Shashanka and Soumya. Stable. It's verified. Maybe 10 seconds laga verify karne ke liye. That's it. It is done. Okay. Guys, these are important lessons to learn. How are the MCQ question from Nyquist? That also we will go. But first, it is the concept that should be fed into mind, and that can be done once I take various Nyquist plots example. Chaliye, time to take the screenshot of this one. Time to take the screenshot of this one. Next one. Next screenshot. Next one. Next. Next one. Next one. We have a stable system. This is just verification. And guys, it's high time. We'll stop now. It's approaching 6:40. So we'll definitely stop. I shall give you one homework. Try it out. We'll solve tomorrow. We'll solve this tomorrow. Sketch the Nyquist plot for GSHS equal to S plus 2, S plus 3 upon S square, S plus 1 and comment on stability. Because they're asking you to comment on stability also. So maybe required you will have to find the critical frequency. If required, you will have to find the critical frequency. So theta starting, theta diving and theta critical will make the complete Nyquist plot. Theta diving and theta starting will give you the shape. Okay, but if you want more analysis of stability, theta critical, third frequency. Theta starting, theta diving, theta critical will complete your problem. Right? Theta starting, theta diving, theta critical. Just remember. All the poles and zeros are in LHP. So theta starting, theta diving with no precautions to be applied. Solve it regularly. Okay. So I hope you will be able to solve this. And guys, apart from that, more important homework. I insist you very clearly, revise today's class again. Because many new tricks, many new concepts are listening. Okay. Some you might be having some little or confusion. ऐसा नहीं सोचना कि it is a difficult topic. It is actually easy. You have to pay your focus. If you are facing any difficulty, revise. And at the time of revision, if you think this is not clear, that is not clear, put it in the doubt box immediately. I understand maybe running time, but sometimes I'm reading most of the comments. Sometimes miss हो जाता है. Yeah, sometimes even reading the while listening to the class, immediately आपको doubt नहीं आता, but you may get the doubt while listening to the video again. So listen it again, make down important points. Okay, if there is any doubt, drop it in the doubt box. But this is important. You have to understand. Okay. Yes. All right, guys. So take this homework, solve this question as well, and then I will come back tomorrow with few fresh questions, and also will tomorrow talk about the NAT and MCQ category. Okay. Chaliye, bye bye. Take care. Let me conclude the class. Prep smart. Stay safe at home and keep learning. Do not deviate from your path. Okay. Chaliye, bye bye. Take care. See you tomorrow. Give your feedback to the class. Learning so important topics like Nyquist. Bye bye. Take care.